Hello students, in this video we are going to learn about the concept of continuity. Continuous means it goes on and on without break. That is the general meaning of continuous in English. You know it, right? Now, what is the meaning of continuity in maths? We are going to take an example and show. Suppose if f of x is equal to x. What does it mean? Or I can say x plus 2. Suppose f of x is equal to x plus 2. You know it is a straight line with y-intercept at 2 and with a slope of 1. So at 45 degrees, I can draw the straight line. So this is the line y is equal to x plus 2. You know f of x and y means the same. And you can draw the line as usual. We draw it in class 10 and class 11. So this is the line y is equal to f of x. Can I draw this line without lifting my pen? It extends both the sides, I know, indefinitely. So I can draw this line without even lifting my pen. Therefore, it is a continuous function. Yes. So f of x is equal to f x plus 2 is a continuous function because at every point, if we find every point x, we find the value of y. And if we join the y's, we can join them without even shifting our hand. That is the meaning of continuity. Suppose I have a function f of x is equal to 1 when x is less than or equal to 0 and 2 when x is greater than 0. Let us draw this function. You know at 0 the function is changing. So I must be very careful at that point. Last year you studied limits, no? Whenever there is a change in the function, you must be careful. So this is 1, 2 and goes on. This is 1, 2 and this is negative 1. This is negative 1. Now, when I want to draw the first line, when f of x is less than or equal to 0, then y is 1. So, less than or equal to 0 is to the left of the x-axis. So, what is the value of the function? The value of the function is 1 and equal to is written. So, for 0, you should put a dark circle. 0 comma 1, you should put a dark circle. So, how is the function now? The function is like this. Do you understand? Now, I am going to draw the second line. How is it? When x is greater than or equal to 0, the value is 2. So, right hand side is greater than or equal to 0. So, I am drawing it using another color line. It is like this. Is the endpoint 0 included here? No. So, I put a open circle. Now, imagine when I want to do this lines, do I have to shift my hand or not? I have to shift. Therefore, it is a discontinuous function. So, to be very precise, the function is discontinuous when you cannot draw it at one stroke. Do you understand? Okay. We see a few more diagrammatic examples, then we start doing problems based on algebraic method. Okay. Now, f of x is equal to modulus of x. You know, f of x is modulus of x is defined as negative x when x is less than 0, positive x when x is greater than or equal to 0. Here also at 0 the function is changing. You can see from negative x to positive x. Shall we draw it and check? This is x-axis and this is y-axis. Now, 1, 1, negative 1, negative 1. Now, we are going to draw the first one, y is equal to, when x is positive, it is y is equal to x. Do you understand? Y is equal to x is a line passing through 1 comma 1. And the left hand part of the curve is y is equal to minus x. So, minus x will go passing through minus 1 comma 1. Now, this is the modulus function. Even though the function changes at 0, I can draw the function without shifting my hand. You can see I can draw it like this and I can draw it like this. I need not lift my hand while drawing. So modulus function is a continuous function. Are you able to understand? Okay, now we are going to deal with another type of function, which is the greatest integer function. Are you remembering what is the greatest integer function? I'll explain to you anyways. F of x is equal to greatest integer function means you need to write it within the squares. You know that, right? Now, we are going to draw the greatest integer function. Listen very carefully. So if a question comes in 1 mark and you are asked to show whether continuous or not, you can draw the diagram and tell if it is continuous or not. 1, 2, 3, and 4. I'm plotting a few points, okay? And you know this is 0. Are you able to understand any value from 0 to 1 means just before 1. That's why I'm putting an open circle. What is the answer for the greatest integer function? Is 0. So this is the first line. Are you understanding? 0. I need to take a line, that's why. So this is the first line. Okay, now 0 is included, 1 is not included. Suppose I am going to plot from 1 to 2. 1 is included and 2 is not included. So what is the function now? The function is this. Same with 2 to 3, 3 to 4, you can draw the function. Now, you can very easily say the greatest integer function is discontinuous. Exactly. The greatest integer function is discontinuous. Second, here 2 is included, 3 is not included. 3 is included, 4 is not included, and it goes on and on. So the greatest integer function is discontinuous at integer points. Can you see that? From 1 till 2, 1 is included, 2 is not included. It is discontinuous at the integer points. Are you able to understand that? But it is continuous at non-integer points. It's a very important theorem. The greatest integer function is continuous at non-integral points. Non-integral means non-integer points. Okay, non-integral points, and it is discontinuous at integral points. Integral points means integers. Okay, so this is the common sense of doing the greatest integer function. So we have done in this video a few questions with graphs. In our next video, we properly take problems and then solve them algebraically. And then when it comes in 4 marks, you can draw the graph and explain, or you can do the algebraic way also. Hope the concept of continuity is clear for you. Now we are going to do left hand limit and right hand limit like last time you did know. In 11th standard you did, the function is limit exists. Now you do left hand limit, right hand limit, and then you make them equal to f of the whatever value it is. Same way, now we are going to do left hand limit, like right hand limit, and check the continuity of the function. Also remember, only continuous functions are differentiable. Continuous functions are differentiable. Okay, still differentiable. Still, all continuous functions are not differentiable. If the function is not continuous, or if the function is discontinuous, it is not at all differentiable. Do you understand? Not differentiable. So continuity is one of the criteria for the function to be differentiable. Like for example, modulus of x we saw. Modulus of x you saw, it is continuous, but it is not differentiable at x is equal to 0, because at 0 the function is sharply turning. Do you understand that? So we will study more of all these things in our next coming videos. Hope up to this is clear for you. So continuity leads way for studying differentiation. So for differentiating a function, the first criteria is it should be continuous, but it is not only condition which is enough for a function to be differentiable, because I told you an example here. We will deal with this concept in the forthcoming videos. Thank you, students.